Hello Year 3 and welcome to today's maths lesson. So today we're going to be doing a bit of a review lesson on multiplication and division. So our knowledge, our ways of procedures, and so the word consolidate means that kind of we're grouping together information. So you have your do now on the screen. You need to complete the missing numbers in the grid. This should be a fairly straightforward activity for you, so press pause, and when you're ready, press play and we'll check the answers straight away. Fantastic. Okay, here you see your answers. If you're practicing your times tables, these should all be very, very simple equations for you to remember. And there's also some related inverse facts in here. So, for example, if you know that 8 times 2 is 16, you know that 16 divided by 8 is equal to 2. Shows how much it's really important that we remember that inverse knowledge. So let's look at today's star words. So one of our star words today is inverse, array, commutative, times, divide. And remember, times also can be multiply, groups of, and divide can also be shared equally. You can share and you can also group for division. So let's start off with a quick recap of our 3 times table. This should be something which is really familiar with us, but I wanted us to look in a little bit more detail and see a few patterns in the 3 times table for us. So looking closely at the 3 times table, here we start off counting. Let's skip count together. 3, 6, 9, 12, 15. What things do we notice by looking at the 3 times table? Well, it increases in jumps of 3. 2 groups of 3 is equal to 6. Therefore, we know that with our knowing that multiplication is also repeated addition, 3 add 3 is equal to 6. 3 add 3 is equal to 9. There's something else I want you to take a look at. 3, 6, 9, 12, 15. Odd, even, odd, even, odd. I think there seems to be a potential pattern. Do you think the next number is going to be an odd number or an even number? And remember, an even number is a number that is divisible by 2. You can divide it by 2. Let's have a look. Let's see what our next number is. It's 18. Another even number, because 80 divided by 2 is equal to 9. So that is a pattern for you to remember when you're recalling the 3 times table. It goes odd, even, odd, even, odd, even, odd. And then obviously that carries on for as long as the 3 times table goes on. Let's skip count from 18. We have 18, 21, 24, 27, 30, 33, 36. Of course, you could go 39, 42 because you've got that pattern of knowing it's odd, even, and also adding 3 on. But we don't really need to worry about that at the moment. So that is our 3 times table. What can we see here? What do we see in this picture? What do we see in this picture? Well, I'm going to tell you what I see. I see 5 nests. 1, 2, 3, 4, 5. I see 5 nests. And what is there in each nest? There is 1, 2, 3 eggs. So there are 3 eggs in each nest. 5 nests with 3 eggs. That is the same as 5 groups of 3. 5 groups of 3 is exactly the same as saying 5 times 3. 5 groups of 3. 5 groups of 3 is equal to what? Let's count together. 3, 6, 9, 12, 15. Good. Again, just to recap so we really understand what our times tables are about. Our good friend arrays. So arrays are incredibly useful for us in our maths learning. We can have a look in arrays in different ways. We can have a look at them with our rows. So a row is going across. So we call this horizontal. It's your row. And then you have your column, which is going up and down. Column, which is going up and down. Everyone say to me, row. Everyone say to me, column. Row, column. Just check that you remember that. So my array shows me 3 rows of 5. I don't think it does show me 3 rows of 5. I think it shows me 3 rows of 6. So let's just change that. It shows me 3 rows of 6. 3 rows of 6. Here are my rows. I've got 1 row, I've got 2 row, I've got 3 row, and I've got 6 in my array. 1, 2, 3, 4, 5, 6. So let's loop my 1 group, 2 group, 3 group. This is showing me 3 groups, rows of 6, which is the same as 3 groups of 6, which we know is the same as 3 times 6. Then let's have a look the other way. I'm going and looking at my columns, which are my vertical. So I've got 6 columns. 1 column, 2 column, 3 column, 4 column, 5 column, 6 columns. I have 6 columns of 3, which is the same as 6 groups of 3, which we know is 6 times 3. I wonder if you can help me spot something here. Well, let's first of all solve our equation. Let's do it. Let's solve 6 times 3 first of all. Let's count it together. 3, 6, 9, 12, 15, 18. 6 times 3 is equal to 18. Let's solve it with our rows. Oh, it's 6. Let's see if we can do skip counting in 6. We're going to be looking at that a bit more detail later in the week. We have 6, 12, 18. Oh, exactly the same equation. So if I know that 6 times 3 is equal to 18, and I know 3 times 6 is equal to 18, I can also have a look at my inverse. So remember that inverse is with multiplication, we know the number of parts, we know the number of groups and how many parts are in those groups. In division, we know the whole, and we know either how many parts are in each group or how many groups there are in total. So they have a relationship, they are inverse, they're related very closely. So looking at here, my array is actually showing me something else. My array shows me that if I split 18 into 6 groups, I have 3 in each group. 18 split between 6 groups, I have 3 in each group. And if I split 18 into 3 groups, I have 6 in each group. It's simple. Let's do another practice. Have a look at this array. You might want to pause. If not, we're going to go straight into looking at how many rows and how many columns, and also doing our inverse. So how many rows have we got? Remember, rows is horizontal. Stay on 3. 1, 2, 3. 3 rows. So we have 3 rows. How many in each row? We have 1, 2, 3, 4. So we're going to draw our rows. So we've got 1 row. We've got 2 rows. We've got 3 rows. What equation is our row showing us? Our row is showing us that we have 3 rows of 4, 3 groups of 4, which is equal 3 groups of 4, 4, 8, 12. We can also have a look at our inverse of this. Here we have 12, which is our whole, and it's been put into 3 equal groups, and in each group there are 4. Let's have a look at our columns. Columns, remember, are going vertical. How many columns do I have? 4. 1, 2, 3, 4. So what is this showing? That when I have 4 groups of 3, it's equal to 12. Let's double check. 3, 6, 9, 12. This is also showing me that when I divide 12 into 4 equal groups, my answer is 3. Now it's your turn. So I want you to look at the array and then copy and complete the 4 equations which are linked to this array. Then you've got some missing number 3 times tables equations underneath. Press pause to complete the activity and press play when you're ready to carry on. Okay, fantastic. Let's have a look at some answers then. Okay, so this is a simple array that we're showing. It's got 3 rows. It's got 2 columns, 3 in each column, 3 rows, 2 in each row. And then obviously that's showing your inverse. And then here are your equations. 6 group of 3 is equal to 18. 3 times is equal to 3 times 9 is equal to 27, and 33 divided by 3 is equal to 11. Again, this is just a recap. This is really good recap for us. It's going to help us looking at some of our topics later on in the week. Let's look at the 4 times table. Hopefully we all know this. I know some of us might be a little bit not as familiar. So let's skip count. 4, 8, 12, 16, 20, 24. Good. You might be able to see that there are some links to another times table. That's right. Any number which is in our 4 times table is also going to be in our 2 times table. 4, 8, 12, 16, 20, 24. And if it's in our 2 times table, it means it's divisible by 2, which means it's even. Therefore, any number which is in the 4 times table has to be even. It's a great way to start with your knowledge, that you know what's going on there. So you know if you're calculating and you're guessing and you're multiplying something by 4 and you get an odd number, you know something's not quite right there. Shall we carry on counting? So 24, I'm going to add 24 on from 24, 25, 26, 27, 28. Can we go next? 28, 29, 30, 31, 32, 36, 40, 44, 48. Again, they're all even. You can also, if you've got a bit of time, you can also, if you compare the answers of the 2 times table and the 4 times table in a strip, so have the 2 times table on top and the 4 times table on the bottom, you can see there's some relationships between them. Wonder if you can spot them, and if you could put something up on Seesaw. Right, moving on. What can we see here? What can we see here? What can we see here? Well, I can see 1, 2, 3, 4, 5, 6 pencil pots. 6 pencil pots. How many pencils do I have in each pencil pot? 1, 2, 3, 4. I have 4 pencils in each pot. I have 6 groups of 4. We know that word groups of is the same word as times. Let's solve this. How many pencils do we have here in the pots? We have 4, 8, 12, 16, 20, 24. 6 groups of 24 is the same as 6 times 4. Let's have a look at another example. Cookies. How many cookies do we have here? So how many plates do we have here? 1, 2, 3, 4, 5. I have 5 plates. How many cookies on each plate? 1, 2, 3, 4 cookies. So I have 5 groups of 4. I know that 5 groups of 4 is equal to the same as 5 times 4, and it's equal to what? Let's skip counting 4 in our 4s. 4, 8, 12, 16, 20. Let's have a look at it again with our array for this. We should be going this. How many rows can you see? How many rows you can see? You can see 1, 2, 3, 4 rows of 8. Let's count how many we've got in each row. We've got 1, 2, 3, 4, 5, 6, 7, 8. Oh, my 8s are difficult. My 8s are difficult. I'm going to count them on in my 4s, in my groups of 4. So I'm just going to count each group, and then I'm just going to be adding it. So follow with me. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 16. 1, 2, 3, 4, 5, 6, 7, 8. 24. 1, 2, 3, 4, 5, 6. 32. So 4 rows of 8 is equal to 32. 4 groups of 8 is equal to 32. Let's have a look at our columns. Let's look at our columns. 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 4. Let's do our 4 times table. 4, 8, 12, 16, 20, 24, 28, 32. So 8 groups of 4 equal 32. We could also do our reverse division facts, our inverse. I know that 32 split into 8 groups is equal to 4, and that I know 32 split into 4 groups is equal to 8. You might have spotted a little link between the 8 times table and the 4 times table, but we'll have a look at that later in the week. What does this array show? Pause the video now, see if you can quickly talk your way through it, and then I'm going to talk through what it shows. Okay, what does it show? How many rows does it show? It shows 1, 2, 3, 4. 4 rows. 1, 2, 3, 4. It shows 4 rows. 4 rows. How many in each row? 1, 2, 3, 4, 5, 6. So it shows 4 rows of 6. 4 times 6. So I'm going to quickly count. I'm going to skip counting 6. If you don't know it, just count along the dots as best as you can. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 12. 1, 2, 3, 4, 5, 18. 1, 2, 3, 4, 5, 24. So if I know that 4 groups of 6 is equal to 24, I know that 24 split between 4 equal groups is equal to 6. Remember that equal groups phrase that we used during our fractions. Right, let's have a look at our columns, so our vertical. 1, 2, 3, 4, 5, 6. I have 6 rows of 4. Let's skip counting 4s to work out how many there are, just to check they're the same. 4, 8, 12, 16, 20, 24. So 6 groups of 4 is equal to 24. So 24 divided into 6 equal groups is equal to 4. Fantastic. It's time for your independence task. Again, it's writing an array, and you need to fill in the missing numbers. So press pause to complete the task, and then when you're ready, press play. So you're looking at, again, another array of 24. Below is, so hopefully identify the commutative, which we'll go into in a minute, and the inverse, and then filling in the missing numbers. D, I was just trying to check that you're paying attention. I put the product, so the answer, at the front. Still the same thing. Remember, this equals sign means the same as. Okay, moving on. Commutativity. Commutativity means in a multiplication, and actually an addition question, we can add it in any order. 3 times 7 equals 21. But if we look at 7 groups of 3, that's the same as 21. We've been looking at this with arrays. 3 groups of 7 and 7 groups of 3, exactly the same. We can also link it to our idea of repeated addition. That multiplication is just repeated addition. Multiplication is just repeated addition. So, a quick task to refresh your memory on commutativity. You've got to fill in the gaps of these multiplication equations. And then, can you write for question 6, what multiplication equations does this tray of muffins show? Challenge, can you write the inverse? Press pause to complete the task now. Fantastic, let's see how you've done. Here you can see simple commutative law questions, which I remember in class we all were fairly comfortable with them. And again, this is just another example of an array, but instead of using dots, we use muffins instead. And then your little mini challenge, could you write the inverse? You should see now it's all, hopefully, the ideas of inverse and commutativity are coming back and you're remembering them. So with all of that, it's reasoning time. I told you there'd be more reasoning. So I arranged 24 star stickers in this array. What multiplication equation does it show? In what other arrays could I arrange them? What would those multiplication equations be? So you might want to start by drawing out this array on a piece of paper. So you've got 4 rows of 6 or 6 rows of 4, however you want to see it, and start that off as your starting point for this question. And then you need to think about this, be a little bit creative. Press pause, and then when you're ready to have a look at, look and see what I came up with my answers, press play. So, first of all, what does this multiplication equation show? This array, does this show? What multiplication equation does this array show? I got there eventually. So let's have a look, for example, in my number of rows, it shows 1, 2, 3, 4, and I have in each row have 1, 2, 3, 4, 5, 6. So it shows I've got 4 groups of 6. Therefore, I know, because I know how it works with an array and I know commutativity, I know it also shows 6 times 4. I know my product of these two is 24. So what other arrays could I arrange these stars into? So what I'm thinking of is what other multiplication facts do I know of linked to 24? Well, I know that 24 times 1 is equal to 24. So I could just have one long row, or I could have 24 columns with 1 star in each one, or I could have one long row with 24 stars in them. I also know that 12 times 2 is 24. So I could have 12 rows with 2 stars, or I could have 2 columns with 12 stars. I could also have 8 rows with 3 stars, or 3 rows with 8 stars. Just a different way of breaking up all the different multiplication facts for a particular product. Hope you've enjoyed that one. I think that was quite a good one. We might do another one based on that later in the week. If you would like some more of a challenge, I've got one for here. Start this rhythm. Clap, clap, click, clap, clap, click. I want you then to carry on the rhythm. What will you do on the 15th beat? How do you know? What will you be doing on the 20th beat? Explain your answer. So, upload your work from Seesaw for this lesson. You could even, if you want to upload a video of you doing this challenge, that'd be fine. But looking forward to seeing your work. Hopefully this has been a good, I don't want to say easy, fluent start to the week with our maths. Okay, can't wait to see your work, and we'll see you tomorrow for maths.